Station and low carbon networks engineer for Western Power Distribution. After joining E.ON UK's graduate scheme as an electrical engineer, he held a number of operational roles in the Midlands area, delivering major electrical infrastructure projects. And now, what are you working on? You're a network and strategy manager for Western Power Distribution. So, the floor is yours. Thank you.
To me, thank you. Well, welcome everyone. Thanks for letting me come here to talk to you today. You said in the introduction today that I'd come here with some problems and solutions. I can definitely deliver on the problems. The solutions might be a little bit more limited, but let's maybe we can have a bit of a discussion today and see how these thoughts are developing in this area. So as I said, I'm the Network Strategy Manager for Western Power Distribution. So my team is responsible for looking at the demand and generation growth across all 4 license areas of our network. We predict where all the low carbon technology is going to be clustering, where the domestic and commercial growth on the electricity system is going to be happening across our areas. And we predict what sort of timescales and criticality might be created by those different developments across our network. I was at a talk a couple of weeks ago, and one of the senior members of the regulatory body that we work under, Ofgem, was saying that the energy industry in the UK is probably the most exciting that it's been for the past 100 years. And I think, having been in the industry myself for about sort of 15 years now, I'd say that's pretty much true. Every year we have more and more challenges. And I think this year is definitely going to be the year of flexibility. So we're moving very much from a passive network operator to an active system operator on the distribution level. And that is bringing a whole host of challenges, which hopefully I'll be able to talk to today. So what I think I'll set it out is that we've got 2 main themes to talk about in the next sort of 50 minutes or so. I think perhaps they are related, but to give sufficient time to discuss either of those, perhaps we'll have sort of 15 minutes worth of presentation now, about 10-15 minutes of discussion, and then another few minutes of presentation after that to talk about the second theme, and then a bit more discussion. We can bring things round and close later on. So for those of you who do not know Western Power Distribution, then we are a distribution network operator. We are the largest by service area, if not by the largest by customers and by demand. So we've got the biggest number of assets, which account for about 25% of the UK, and we're responsible for the East Midlands, West Midlands, South Wales, and South West. So we cover a massive area full of different sort of conurbations, large cities, rural areas. So a real big mix, and even some islands as well down in the southwest. So as a network operator, we kind of have 4 main roles. We keep the lights on, it's one that we're pretty good at. We maintain the equipment, we fix the network, and we connect customers. And those are all sort of traditional things. We've always done those. We've always tried to innovate within those to keep us at the forefront. But today I'm going to talk to you a little bit more about the transition from network operator to system operator and how that's changing our roles and responsibilities. So as we start to see huge changes across the electrical and energy networks in the UK, then this is facing us as WPD pretty significantly, because we operate such a large area full of different sort of regions and different variations of customer requirements in those areas. Then that means that we have to have an agile way of planning our network and making sure we're delivering everything for customers. So you can see our predicted increases for demand and red, generation in green, percentage-wise out to 2030. So there's no reduction, no negative numbers there, so we're going to be growing in terms of what we need to supply on the network. And you can see in the Midlands, pretty much dominated by demand there. So although we're going to have a small increase in generation from what we've got at the moment, there's going to be lots more low carbon technologies, electric vehicles, new industry, new housing developments, and that is going to significantly hit the Midlands. Whereas when we come down to South West and South Wales, we see that generation there is dominating, and that's primarily because those areas are the sunniest and windiest of our network. So it means that we can't have a single way of connecting and managing demand and generation on a network. We can't just use a cookie cutter approach and to develop our networks. We need to make sure that it's fit for the exact area that we're going to be supplying. And those kind of challenges about the future demand and generation growth are really sort of driving the forefront of what we're doing at the business. And this is the DSO transition. So moving from a passive network operator, we build a fit and forget network, size it for 40 years worth of very, very steady growth. We're no longer in that world. Things are changing too rapidly. Customer expectations are different. And so we're moving to becoming a distribution system operator, one where we actively manage the network. We're not building big passive assets to accommodate any future demand and generation. We're incrementally managing the network and making sure that we're netting off generation and demand close together to be able to fulfill all our customer needs. So unfortunately, that doesn't mean that we get rid of any of our responsibilities. We still need to develop and maintain the efficient coordinated network. We still need to facilitate competition, but we also need to do that in a different way with a lens on these new roles. So certainly facilitating new flexibility services, developing new markets, improving the resilience and security when we're looking at new types of variable and volatile load and load on the network, and doing so that we're not just abusing our monopoly position. We're making sure that we're being open and transparent about what our needs are in a particular area, so that if we're not the best people to deliver that infrastructure, then there are other services and flexibility that can provide those services. So all those are sort of new challenges that we're just getting to grips with at the moment. Two things that I wanted to talk to today are how we can look at developing whole system markets, particularly for enabling flexibility, and whether there are any sort of unique characteristics about those particular markets as to how they apply to the distribution network versus how they're traditionally applied at a transmission system level. And then also the second part is looking at how we can value flexibility, depending on where the flexibility is located. Does it have a different value? Does that value change throughout the year? And how do we make sure that we're achieving the correct value at any one particular time for a particular asset? So flexibility on the system isn't something new. We've not created it this year or anything. It's always been there, but predominantly it's been the realm of large power stations connected to the central transmission system, and predominantly used for balancing supply and demand on a national level. What we're also seeing is that there is electricity network smart grid flexibility. So we have transfer capacity from adjacent areas. We have lots of different technologies, dynamic asset rating, automatic load transfer, active network management. All these things enable us to control demand, control load across the network, shift it around as to how we see fit. So those are things that are innately within the network, that are within our control, that generally don't really have any influence directly on customers. Those are just things that we are able to flex ourselves and still accommodate everything that customers need to do. We're also starting to see this third tranche here of distributed energy resources, whereby customers who have generational demand that is able to shift or alter its behaviour and provide flexibility up to the network, then this is a particular great source of flexibility that we might be able to tap into and use. So we really don't want the customers just to be connected to the electricity system and go about their business unabated without any particular signals or drivers. We really want them to, if they have the ability to flex, to pass that on, so not only can they derive benefit from them, but the whole system can derive benefit as well. And this is really where DSO sort of fits in. So we're not planning to look after the central power stations. We're not looking to supply, to balance the supply and demand on a national level. We're not looking to manage the frequency. But as a DSO business, then we will be managing our own internal flexibility relevant to our assets, and we're also going to be managing the customer flexibility that's connected to our network and making sure that we get the best benefit out of those, and we're tapping into the value that can be provided by flexibility on that lower level. So what we're now seeing is a deepening of potential flexibility markets from traditionally what would be the national level where we have, even this is expanding now. So because of things like TER and other European-wide markets, it's not just the UK flexibility market that the national market is operating on. It's a kind of pan-European. We've got interconnection and an increasing amount of interconnection with other European countries, and that allows really for any, used to be over 50 megawatts, but that's decreasing now to over 1 megawatt unit. We'll be able to bid into these national markets and satisfy the national supply and demand balancing. But really in the UK we have about a 60 gigawatt peak on that national market, where we have significant oversupply in the amount of generation and assets that can contribute to that. So no winter margin warnings that we've had recently. We're still oversupply in that particular market. And so on a national market with all those players bidding into it, then the current systems work very well. What we're starting to see now is an expansion of these markets down to aggregation at GSP group. So smaller entrants aggregators are beginning to pool up resources connected to the distribution network and do that at GSP group level. So there's about 32 boundary constraints across the UK. Might be corrected if anyone knows that, but around about 32. They tend to be, again, attracting the sort of 1 megawatt to 50 megawatt participants. But within those GSP groups, then maybe they might have a 5 gigawatt peak. So we're already starting to see that for a GSP group market, it's a lot smaller. There's a smaller number of participants, in a tighter market, less oversupply. And these different levels represent the configuration and the topology of our network and how it's all made up. So GSP is the next subgroup. So a GSP group comprises of a number of GSPs, and each one of those GSPs will have their own constraints and limitations, and we're probably talking about a 2 gigawatt peak there for each one of those GSPs. And as we start dipping down into the lower voltage levels, BSPs, maybe a 300 megawatt peak, primaries, 50 megawatt peak, HV substation 1 megawatt peak, and an LV connection maybe 200 kilowatt peak. At what point are we able to sort of say that actually, definitely a nationwide market and running pure market principles works? There's enough competition, there's enough oversupply to be able to not be distorted. That certainly works. But at what point within these different voltage levels and these system architectures do we need to kind of hit a hard limit and say, well, actually, we don't think that we can apply market principles at this particular level? Taking it at its most crude example, an LV connection that might be a feeder, an LV feeder running along the street. So you're going to be competing with that capacity between you and your neighbours. If everyone wants to charge their electric vehicle at 6 p.m, are you going to be able to compete financially against your neighbours, or does there need to be some sort of hard limit? How do we employ market principles when the constraints mean that the pool of participants is going to be limited? Geographically you can't, you're going to be limited by the pool of people that you can be working on within that market. And I think that's the sort of question really that we're starting to look at now, is that certainly GSP group, GSPs, BSPs, probably even down to primaries, you've got enough participants within that geographic area to actually drive a market and have that not distorted between a dominant player. You've got enough oversupply in that to be able to satisfy everyone's needs. But at what point in the lower voltages does the onus fall away from the market and actually should be driven by infrastructure and just making sure that people aren't inhibited from doing what they want to do? But there's further complexity that we also need to look at as well, this self-dispatch versus system dispatch. So at the moment, the transmission system operator is kind of a trusted entity that has overall visibility about all the decisions that it can make and all the requirements that the system needs to keep within limits. And by having a single controller dispatching those actions, you don't necessarily need to give the full amount of market information to be able to understand what the potential alternatives are. You don't need to calculate all the alternatives there of actions. You just need to try and optimize through central dispatch from the system operator and make sure that you're trying to do things, towards the best of their abilities. Is that same sort of ability, does that work across all different voltage levels? It might work from a system operator point of view, where maybe you might have, 1,000 different participants, 1,000 different tweaks that you can make on the system to be able to keep it in order. But when you start dropping that down to the lower voltage levels, we've got 29 million electricity customers. Maybe a multiple of that in terms of connected devices onto the network. Are you able to actually centrally dispatch that, or do you need to have more local dispatch? Is it sort of rules based? How does that work? And that complexity of describing the constraints also features into that sort of problem as well. So the transmission boundaries, you've got 32 there. It's not trivial, but it's a manageable number of transmission system boundaries to be able to understand, describe on a real-time basis and ensure that you've got correct operation of the network within those particular constraints. But when we start dropping these different actions down onto the voltage level, then the number of constraints not only increases, but also their interrelation. The interplay between those constraints also maintains. So you're going to have nested constraints of GSP level, BSP level, primary level, HV, LV. How do you provide sufficient information about what those constraints might be so that you can guide how much availability of network there is for a particular participant to access? Is it going to prohibit them from doing certain things, or is it going to provide new value streams for them to offset these constraints? So the complexity of describing those constraints, is one that we're working on at the moment. I don't think anyone's really understands how many LV constraints or boundaries there would be. Typically on the LV we build it big enough so that there aren't any constraints. But clearly, as we move into a world where there's a lot more variable and volatile demand on the lower voltage networks, then that's not sustainable. We can't build a passive network big enough for everyone who wants to potentially charge their electric vehicle to do so. So we're going to need to start putting constraints on and managing that in a fair and market-led way. And then coming back to that central dispatch, who is going to be responsible for deciding which is the best action to take, and does that change depending on what type of service there is? So at the moment, National Grid has this SNAPS thing, System Needs and Product Strategy. They have effectively 3 different products. Response, which is very much about managing frequency, so it's very, very quick action, pumping energy into the system or taking energy away to be able to maintain that frequency. That is clearly going to always be within the realm of the system operator, but it might be facilitated by other methods deeper down into the network. They've also got this Restore product, which is about pushing megawatts, gigawatts of energy back onto the system. So if they have a large power station come offline, then or dispatch at different times suddenly become unavailable, then they use this Restore product to pump sustained energy along a number of hours across the year, across the day, to make sure that they're keeping the future, maintaining the ability to manage the frequency out into the future. But there's also this reactive power component as well, which is changing the characteristics of the import and export on the network with respect to reactive power, making sure that it's providing enough stability. The interesting one about the reactive power is that it's not a one-to-one unity ratio for pushing that across the network. So whereas you can almost associate the conventional real power products with having a one-to-one relationship, you push 1 megawatt in, 1 megawatt comes out effectively. With reactive power, depending on the gain of the particular components that you're connecting on, then it might have a positive or negative effect, and it's non-linear. That means that it's very, very much more difficult to be able to understand what the effect of injecting or absorbing reactive power on the network is. So certainly the thinking that us as a distribution system operator is coming at is that for real power products, there's probably a very big market where we can joint procure and both people can operate these services, and we can work together to be able to access those services. But when we start looking at reactive power, particularly on the distribution network, then there's only one person who can be in control of being able to understand what the reactive power envelope of operation on a network is, and that will be us. And we would have to be more in control about these particular products. So certainly there's a different responsibility of the level of, the level of responsibility should sit differently across the system for those particular products. And so that might lead into the market segmentation. It may not be a single uniform market for all products and all services, but there might be some sort of segmentation differential for how we dispatch those services. So to kickstart a bit of discussion, these are the types of questions that we're thinking about at the moment. I'll open the floor up at the end of this slide here. Do we think that the dimensions of flexibility and the participants who are able to provide that flexibility, do they sort of inform the market principles? Does, depending on the magnitude of those flexibility participants or the number of people operating within that market, should that change the way that we operate that market, or should there be one uniform market for all services, maybe with a bit of segmentation between that? And aligned to that, can we operate the distribution flexibility markets in the same way as the transmission system markets have operated? Is that a fair way of doing things, using those same kind of procurement timescales, those same products? Or do we need to look at new markets and new ways of doing this? Should there be different boundaries for sub-markets that kind of have an ability to settle a smaller market, which will then inform a much wider, larger market and try and reduce the volatility across the system? And is there a natural economic balance between how whether those products and services are market-led, or whether they're either mandated or fixed in terms of compensation for those particular services? How does that work? And we see a variety of those already in the marketplace, but are there new avenues that we need to explore to be able to do that? Do these current frameworks work in the complexity? Might we need to change the transmission system operator products even further than what they're planning to do at the moment, when we start talking about the many millions of electric vehicles that might be operating as virtual power plants circulating around the network, and being able to offer a significant more flexibility to the network than anything that we can derive for our conventional asset. And with that, when we have an oversupply of actors on the network, how can we maintain that the actions that the system operators take still remain residual, and the bulk of the activity and the settlement is conducted by a market? could it be that the markets get too complex for us to actually arrive at a physical solution that we can deliver via the existing asset? And does that impact on the sort of trading volumes of these new platforms? Do they need to be changed as well? And then finally, do the different on those different services, do they require different markets to be operated, or can we just apply the same principles and slightly tweak them to fit the different market products and services that we were looking to procure across the whole of the system? So a few questions there, sort of a quick rattle through a few things that are happening in the industry. I'll open the floor up to see if anyone has any thoughts or considerations.
Anyone has opinion, Stan? Yeah?
To what extent is it possible that market principles could devolve down to the individual consumers, I mean domestic as opposed to large and industrial? You could imagine it could happen in the sense that people might be offered different tariffs depending on their willingness to respond flexibly, for example. But there are questions of social acceptability about that, and there are questions of whether poorer people would in some sense be disadvantaged. But it's possible in some sense. It's what has happens with telecoms, for example. You get better service, you pay more. But now there's so much telecoms that everybody gets good service. It's just not obvious.
Yeah, I would totally agree. I mean, yeah, we do an excellent job of providing a uniform level of service to all of our connections across our network for 27 pence per day per customer. So, very, very low rate, lower than the equivalent telecoms. We need to make sure that we maintain that and still deliver a consistent service, particularly to those vulnerable, fuel poor. And it's perhaps not exactly entirely too clear that if we allow a real free market to operate, whereby those that can perhaps extract the most amount of value or a better service, if they're able to pay that differential price, whether that does that disadvantage some of the others that perhaps we need to keep a consistent base level for everyone. So it's quite a challenge, I think, being able to do that.
Yes, Andrew.
I'm wondering how you can keep system operator actions residual for vehicle charging when, in principle, in some areas at least, the vehicle charging load in total will be greater than the current domestic load. So it's a bit like having a pub where you pay all the people in the area not to come and have a drink. It seems a strange way of conceptualizing your market, that rather than providing and allocating the network capacity at the right time and charging for it, you reward people for not using it.
Exactly, yeah. And if you have significant oversupply in that, then I think that is a definite danger.
I'm not sure that someone who is not planning to come and have a drink sees that they're supplying the pub with not buying a drink. They probably see it the opposite way around, that when they want a drink, you should be willing to sell them one. Yeah.
No, I think that's. I think if it was left alone to sort of to sort of market principles to be able to, you could quite easily get into that sort of situation. I think where we would like to see things getting is that there clearly needs to be some incentives or price signals to incentivize people to use it at the correct time. But we need to be careful that we don't just completely let price dictate that. We need to make sure that there's an underlying infrastructure to be able to deliver the service. The electricity infrastructure as a kind of percentage of GDP is a very, very small percentage, and it doesn't. It's fairly obvious that you need to have a sufficient supply of electrical energy to be able to do all the things that we want to do to increase GDP. So it should make sense to invest in that, and you see the returns later on. But that's perhaps not quite where the economic regulator is at the moment, really, in that they want to see more market competition coming in and really, I think, feel the pinch first before going forward to that. So it's an interesting analogy, really, and I would definitely take that one forward.
Jalal, you had a comment?
Yeah, I have more of a question rather than a comment, which is, okay, I understand that there's indeed a very big need to discuss what would be the market design at the distribution level, but you seem to be starting from the point that, let's say, whatever flexibility is available at the distribution level of the network is there to, let's say, be used by the DNO only. At the same time, there may be a lot of need, let's say, to either coordinate with the TSO or even aggregate the flexibility, and there may be a value to export it upstream. I don't know how you think about fitting that into the...
Yeah.
It was written in one slide that there was a coordination. But it's
Yeah.
true, but still, he put it on this level.
So I guess the boxing there is perhaps a fallacy. So we're not going to be ring fencing the flexibility for us to use it for our own purposes. Then the whole point of us as a DSO has to be that we're a neutral market facilitator. So we not only have an opportunity to use the flexibility on our networks, but we also need to provide sufficient capacity on our networks so that people can export energy or import energy and provide services all the way up the system. And that is, it's one of the difficulties that we've got with the current drivers for flexibility on the network is that the providers of flexibility want to access all markets, and so they want to have unlimited capacity so that they can potentially participate in all markets and not be constrained, whereas the actual value to the system is putting the flexibility where it is constrained and providing additional capacity on the network. And that's not something that we've managed to really to come to grips with yet. We're very much opposing points of view, really. So hopefully we can, by us providing a signal to where we think flexibility would be best sited and providing a revenue to those flexibility devices, then they can start being put in different areas, providing some value back to the system, and also in the time where there is latent capacity can start servicing other markets.
Yeah, because I'm wondering, sorry if I may follow up, I'm wondering if providing a revenue, you could, let's say, provide this kind of access to the upper levels and
Yeah.
get an income out of it.
Yeah. And the whole point of us as a company is to try and maximise the utilisation on our network. So we want people to be pushing and pulling watts across our network. It's about, we've traditionally tried to create our network so there are no constraints, and now we're sort of moving to this place where actually constraints are okay as long as we can have mitigations to be able to do that.
I have a side question to that. Will you be profit-seeking in this process? If there is flexibility going upstream, are you going to cash some money, or are you just facilitating?
Just facilitating. Well, so we would achieve profit anyway by being a more efficient network, by having more watts pushed through our network than what we have assets. Yeah. So we won't be pushing a revenue on top of the flexibility, but it's.
There was Jalal first.
Yeah. So following the same questions and question 2 here. So between the two alternatives, having only DSO level market or extending the existing transmission market, what's the current status in UK? I mean, which option is likely to be happening in UK? Do you have any insight about that?
A really interesting point. So the regulator has tasked industry to work together to be able to come up with a number of different market models about how we see the market, transgressing, and we've come up with 5 different market models. 2 of them are the polar extremes, so the full TSO led, where the system operator controls all the flexibility across the network, The DSO-led model is where it's that ring-fenced model. And then there's a price-driven flexibility market model, a joint procurement market model, and then a kind of a supplier hub market model where an independent person looks after constraints. There hasn't been, so we've presented all the information, we've looked at the complexity, we've drawn up sort of impact assessments as well. It's with the regulator at the moment to kind of assess. I'm not sure whether they're going to come down to a defined answer, but I think if I was a betting man, then it would be the joint procurement model that they're going to be looking at. So, you know, allowing all markets access to all facilities and multiple routes to accessing those facilities through multiple markets, and just, you know, I guess hoping.
And then we're gonna clear the market with the TSO, or?
Yes, yeah. So the kind of market will be operated by whoever's procuring those particular services. So for a national market, that will be the TSO. For a regional market, it will be the DSO. But it could also be a supplier as well that will be looking to try and offset some of their imbalanced volumes. And what we're also starting to see is new entrants coming in that also are looking to do some sort of trading. So, you know, who knows where the future will go, but certainly those people who have access to the biggest amount of flexibility and control of flexibility might be the ones that we need to watch out for. So, you know, Fords, Nissans, Teslas, you know, these worlds, if they've got a lot of flexibility for electric vehicles, you know, why wouldn't they use that and bundle those as a service rather than just, you know, selling vehicles? Perhaps.
Just, well, two quick questions. Patrick and then...
Okay. yeah. So I understand that you're using some grid flexibilities to try to have more or less a copper plate.
Yeah.
So what are the incentive for you to do that? What are the rewards for you? And the second part of the question was more: are you the asset owner or not? Who decide to build the grid?
Yeah.
And how do you perform this trade-off to keep the residual operation? And once again, is it possible for you, for example, to install an electrical battery to do something or not? Are you allowed to do that?
So on the energy storage, that regulation has just come in, or it's just been drafted and will be passed in April. That prevents us as a network operator from owning and operating energy storage and any generation as well. So we can't do that. We are the network owner. At the moment, we see DSO, system operator, and network owner as a combined role. We think that there's too much complexity to split those two, but the system operator has made that split, although perhaps not as cleanly as what it would do. But the general incentive on us to do it is we are regulated in the UK under a TOTEX, so capital expenditure plus operational expenditure, and we are rewarded not just on purely capital expenditure, but across that TOTEX basis as well. So theoretically, if we can save more money through operational costs than we can do by deferring capital reinforcement, then that is the option that we should be doing, and that's really where we're progressing.
I need to take a last question and then we move
Yeah.
on with that.
Yeah, very quick. Andrew has its earlier comments about electric vehicles in particular. They are going to be massive in their requirements, and if they all require it at the same time, that's something that simply cannot be managed.
Mm-hmm.
So we've more or less got to find a way of managing that flexibly and spreading the load. So if we do that, there's so much there cannot not be used effectively to smooth everything else. You don't have to worry about, you know, when people want to have their fridges on or whatever, because that's trivial by comparison. So they could get a uniform service.
I think this.
You tackle that one big problem and
Yeah.
solve everything.
I think that this is the kind of the real problem that we're trying to solve at the moment. That theoretically, on an engineering level, you should be able to satisfy everyone's need through the existing infrastructure. But the bit that we haven't quite fully tested is the customer acceptability and behaviour. When you come back to charge your electric vehicle, you know, or buy your pint in the pub, you know, you might not want it, you know, when it's available. And
That's not to set you up. I actually showed the results of our managed vehicle charging trial yesterday and discussed charging electric vehicles from the customer's perspective. So I'm afraid the rest of us know that it is possible to persuade people to manage their vehicle charging, because I presented it.
I suppose it certainly it is possible. I think we would question.
We've showed it's possible in the sense that we've taken mass market consumers and got them to accept managed charging of their vehicles. It's entirely possible.
Yeah, the thing that we're looking to pursue at the moment is whether there's sufficient price incentive on someone to actually do that. So the distribution charges are around £100 per year at the moment per customer.
Fundamental problem, of course, that no one gets any reward for not using the system to its maximum capacity if they're in profile class 1.
Yes, yeah.
Basically, if I pay £100 a year, I can go to the pub and drink whatever I want whenever. Now you've got the problem of persuading me not to exercise the contractual right you've given me.
We can profit of that comment for drifting towards the valuation of flexibility,
Yes,
right?
indeed. Jolly good. So again, ensuring the value within the markets. A quick recap on the different kind of constraints that we have fluctuating down into our network. Same slide as shown before. But basically what we're sort of saying is that flexibility, depending on where it's situated, if it's on the LV or if it's on a GSP level, will have the ability to influence a different number of these constraints and provide different types of value back to the system. And it can only really work, a flexibility device can only provide a solution and mitigate a problem to one of the upstream constraints. So the biggest value to the system is to have everything connected at the lowest level. But of course that's not necessarily where the markets are at the moment, and being able to guarantee access to those other more lucrative markets, particularly at an LV level, is very, very difficult. So, what we would like to, again, prime some sort of questions up is, does the value of flexibility increase as we delve down into the network, and as it can provide more benefit back to the system? Should that be reflected in the value of that? Or are we anticipating that there is always going to be more oversupply of flexibility, particularly down at the lower levels, which will perhaps drive the price down as well? So you won't necessarily see that increase of flexibility, price of flexibility as we move down into the lower voltages. And comparing the markets that we'd operate at the transmission system with those of the distribution system, can both those same market principles derive fair value for the flexibility? Is there enough participants who equally value their flexibility and can bid in and vie for that system need? Is that going to be able to work across all voltage levels, or do different markets need to be operate depending on different different locations? The point about flexibility, and we touched on earlier on, if you've got more flexibility in a particular area, then you've got the capability to supply. Does that stop becoming a solution, particularly if it's operating in the wrong direction? And does it become an issue? And how do we stop it from being gamed? If everyone got together and decided that they were going to charge their car on a Thursday at lunchtime, would that be an issue for us? And how do we stop that from people from having the market, the tail wagging the dog? And then finally, how do we value flexibility in the additional short-term optionality that it might be able to provide? So we're going through a very uncertain time. We don't really know what the future investment pathway of the network needs to be. Should we be spending more on flexibility now to be able to understand what the actual consumers are going to need into the future? And should that be recognised through flexibility pricing, or should we just take it on its merits with our best view of the world as it stands now? Again, open the floor.
So any comments? Any questions? Yes?
So, if we had just sort of a mental experiment here, if we had a set of products which people were prepared to bid for at different levels of in the network, and you were to receive all those bids at the same time, would you theoretically be able to decide which of them gave you the best value?
No, I think it's in short. So we'd that system works very much on a transmission system level. In the distribution network, we tend to rely on more nudge signals through pricing to try and shift people to a particular behaviour. And that's traditionally worked very well. Economy 7, great thing, worked very well and did exactly what we needed to do. But it was very simple behaviour, and it was a kind of single option for people to take. When we start getting down to very individual behaviour, individual networks, the complexity of that is probably not uncomputable, but it's very, very tricky, and certainly beyond our capability that we've got at the moment. Even describing our network to that level would be sufficient difficult problem.
The point I'm trying to get to is if you had the choice between a flexible option in one location versus another location, or at one level versus at a higher level, how easy is it to make the decision how valuable that is to the network?
Not very easy really. So we tend to have to simplify the problem down into a particular, look at it through a particular lens. So try and equate the blocks of flexibility to having similar properties, and then compare them on a like-for-like basis, and that's the kind of assessment that we're doing. But depending on where, that is an oversimplification of the problem really. There are greater benefits from having things further down, particularly when you start looking at losses on the network or even additional optionality. So it may be better to curtail something in one area and bring something up and have the network more balanced, because then you've got more headroom for other actions to take that you might not know about. We have the same problem at the moment with optimization of networks. Do we configure our network so that when the power goes off we can reinstate customers as quick as possible, or do we try and minimize losses, or do we try and reduce the possible risk of failure and the consequences of failure? And it's a juggling game that we play all the time really.
Andrew, yeah, and then we'll follow up on that.
You've presented, I think, a number of disjunctions. Do we do this or do we do that? There's a series of open questions that you're dealing with. You said, I think, that your network is actually very cost effective. One of your problems, if you have to start rationing it, which is what flexibility is, it's the other side of rationing. You're paying people not to use something which doesn't cost very much. You haven't presented the disjunction of saying, how do you balance significant increased investment in the network, deal with these new load classes, as against flexibility? You presented it in terms of investment isn't possible, you can't do it fast enough, you can't persuade people to allow it, and therefore you have to constrain the future energy system by penalising people, and if the penalties, or rewarding them, and if the reward becomes too high, you create extra costs on the network to provide the rewards for people for not using it. Is that balance between investment and managing flexibility part of your disjunction?
I think that that's an interesting argument there, and one that we're battling with internally. And I think in terms of the investment, us as a company, we make more money by putting more copper in the ground. So we would love to go out tomorrow and say, well, this is our investment pathway. We're just going to bang lots of copper in the ground and invest on the network. But we're being pushed by the regulator to sort of say, actually, flexibility can provide a more economic pathway. We don't disagree with that, but there isn't an economic framework for us to access that flexibility. And
I'm not suggesting that flexibility isn't an important lever. My point was you presented it as binary, either flexibility or investment. You said investment isn't possible, therefore everything has to be delivered by flexibility.
No, and it is an oversimplification of it. So I think where we see an actual investment trajectory is that when we start hitting constraints on our network and start hitting those peaks, our first line of defense will be flexibility, because the traditional reinforcement is big and lumpy, and it comes in big chunks, and when we're putting new investment onto the network, it tends to be underutilized for the first couple of years. So we think that actually employing flexibility for those first couple of years will provide the best economic value, and then we can then provide the mass amount of energy by reinforcing the network and building on. So yeah.
Yes. Can I just ask a question, a general question about flexibility? I mean, I think as you described it, it's either I pay you to stay off or something. But in general, full flexibility makes the network, as you say, hard to control. You're not quite sure what's going to happen. The boundary between regulation and the market is something that looks as if it should be in play. And some years ago, I remember there was the Esme Fairbairn Foundation funded dynamic demand. This attempt to, say, regulate how a fridge or whatever worked, so that it was sympathetic to the grid. And there was no real market incentive for that to happen. But on the other hand, that would have provided quite a large amount of flexibility as defined for the network, while at the same time the user is not in control of that flexibility. I mean, essentially there's a regulatory standard for a fridge. It would be one way to introduce it, and just as it can't go above a certain voltage or a certain ampage, or it can't produce transients at a certain level, there'd be something that it won't turn on or off if the obvious signal from the network is telling it it's not a good time to turn on or off. Now, if you think of electric vehicles, it looks like that's an obvious case where the regulatory rule for plugging such a large load in, where the user's perception of value from it is itself so flexible. It's concerned with charging the car over some period of time rather than instantaneous demand. That just looks like something where a regulatory rule that limited flexibility for the way you use the plug, the car, but actually produces a behavior which provides to the system operator and to the distribution network and to the various other levels, provides what it perceives as flexibility. And flexibility means different things to different people. So that would be an example where the regulation may restrict the flexibility of the electric vehicle by giving it a defined mechanism for charging when it plugs in. But the collection of such vehicles would then provide very large amounts of flexibility for the rest of the network. So I don't know, does the regulator think a bit about where that boundary between regulation and market incentives is?
Good point. Yes, they do. They do think about that, and they kind of recognise that. What they're doing at the moment is putting in the sort of the legislation and the frameworks to be able to provide that flexibility. So all new electric vehicle charge points going in the UK will have to be able to be controlled remotely and be able to offer up that sort of flexibility. I think the thing where the regulator isn't quite brave enough is mandating it, in that you must participate in these markets, or at least offer a price into these particular markets. They're looking at more as a sort of opt-in, really, and I think we haven't quite reached the tipping point yet about the requirement for that flexibility to be there, and so we haven't really reached the discussion within the general UK vehicle driver about whether they see that as the future. I think most people, when they're consuming electricity now, don't really think about what the wider impact of that is. And so we're quite concerned at the moment that these discussions aren't happening, and so when it gets to the behaviour of people charging up their electric vehicles, it will kind of just be unabated. They won't really think about it, and there won't be sufficient price signals for them to do the right thing in terms of the system. If it's left to just an opt-in phase, we think it should be stronger and should be a bit more mandated. But that's just sort of our perception, really. I think if various trials have shown that if people are given the right mechanisms and incentives to do a particular behaviour, they will respond. Hopefully that will play out in time.
Just one last question, Simon.
If it's allowed to make it a comment, a little bit, to follow up on this comment, and so I think you in a way you're doing the same, jumping to the conclusion that then it must be a market. So I agree that regulatory approaches may be a sensible approach to unlock many types of flexibility, and just opt out. So not even say that people have to play in this market, but actually say, well, there doesn't need to be necessarily a market for these kinds of flexibility. But the challenge in that, other than the obvious kind of public risk, the Daily Mail kind of issue with which you had with the fridges, actually, Big Brother controlling your fridge. I think that the issue with electric vehicles is you cannot know very well, and that was kind of yesterday's talk, this hidden state. You don't know what people want and need, and you have to somehow ask them. With the fridge, the nice thing is you can kind of extrapolate, right? So you know the behavior, you know how much is in there, and you can do the engineering solution and say, well, we'll schedule it for you, so we don't have to ask. But with the vehicle, you always have to ask because you don't know what the user is planning to do, and that I think is the major difficulty. As long as you don't know with any certainty what the requirements are, you can't go ahead and assume, and you somehow need to get the user into this market, and they may not want to be in the market. And that's, I think, the fundamental challenge here.
All right, but with this very nice comments and great discussion, I think we need to close for this talk. So thank you very much, man. You're staying around.
Yes, I am. Yeah, definitely.
We can have a discussion later today with Ben. He's around. Now we're going to move on to Gilles.